Thanks, guys, for being here. We are really glad to the organizer of PyCon, of course, and to all of you for this opportunity that is really important. Let me introduce both me and Luigi. We are, first of all, two, like you, developers, software architect. The rest is really on LinkedIn, but it makes no sense. We think that it's now time to give back some of our actual experience to a wider audience. And most of all, we are a member of GDG Rome, so if you step in Rome, come and join us. We are just members. This is a great community led by three women, Yuna, Rihanna, and Antonella, that are simply amazing. And so let's start on our talk today. What we will see in the next 30 minutes, we will describe a use case that is based on a real-life scenario that both me and Luigi created during the last couple of years during our job activities. We will first cover what is the concept of release management for us and how we aim to automate the software version change, giving the full power to just one person, that is the developer, in a full DevOps style. For us, a total automated way means that you need to take care only of your commit messages. And I think that each one of you that is a developer take care of your commit message. And we describe, of course, a stack, a technology stack that is a big, big one. So please keep in mind that we have just 30 minutes and we will not have so much time to dig into each single component. But at the end of the talk, you will receive a GitHub repository with the whole configuration of the entire stack and 3 Medium posts that will guide you constructing our solution at home. And so now we are going to launch in 3, 2, 1. Okay, let's start from the real world. The real world in software development is, of course, dominated by chaos. At least it starts with a lot of chaos. And we want to make an order in this chaos. And you will see in the slide that there are lots of developers. Imagine a subset of each developers to be developers of single microservices, for example. They want to release their microservice, and each microservice will end in a deploy of a platform that is a set of microservices. Each team knows what they want to release, but they should also know what the other teams are going to release. So we have to speak, we have to avoid misunderstandings. There should be a good release plan with no overlaps, an efficient codebase organization, and a lot more. And this is where our solution comes to help. Let's start from the beginning. We want to store our release version number inside the Git tag. All of you use a Git tab, of course. We want to have a Git tab with a particular format that you see on the right. That is V, and the first digit is the major version number. Then a minor version number, and eventually the third digit is the patch version. We could also have an optional label that will be a suffix of this label, and we will see in a few slides what does it mean. And we want to have this Git tag totally automated. So you don't have to change manually the values that are in this tag. A workflow will do for you. Let's have first a set of rules that can enable the change of the digits inside the previous tag. As you see, we are giving this set of rules inside your commit message. We will use a particular style for the commit message that is called semantic commit message. This kind of style was born in 2011 in a project from Google, Angular, and now it is used in tons of open source projects. You will see that you have 3 lines separated by a blank line. The first one is the most important one. You should start with a type word. The one you see colored are the special words that trigger a release. The other does not trigger release, of course. You can have an optional body where you can, of course, write whatever you want, and a footer that is not mandatory. You can write in the footer whatever you want, or eventually you can write another special word that is breaking change that will advance the first digit of the label I presented a couple of slides ago. Now we understand that we can code the version change inside a commit message, but we now need a tool that is able to scan the commit message to automate this process. This tool is an open source tool. It's called Semantic Release. It's written in JavaScript with the Node.js framework. And the most important thing is that this tool defines a life cycle that covers the whole release management process. It also uses a pluggable architecture, so you can extend the behavior of the tool with a lot of plugins that support several languages, Python of course, and several different package managers and build tools. So you can, of course, use in your case pip or PI to publish your packages and so on. It's also an open source tool with a great support and a great community. And another important thing is that the configuration of Semantic resides in a single descriptor file that you can push on your root. You can also centralize on a repository to push on other projects. This file could be a JSON file or on a YAML file format. And it describes, of course, the flow you decide to implement with Semantic Release. I stated in the previous slide that there's a life cycle decided by the Semantic Release implementation. This is the plugin life cycle. Each time that you insert a plugin in your descriptor, in the declaration part, Semantic will execute the plugin in the execution order you have declared in your descriptor. And for each plugin, it will trigger a state. Of course, not all the plugins may have implemented all the steps in this life cycle. You will see on the right that we use a few more plugins that enables other behaviors in Semantic. For example, the commit analyzer that analyzes your history of commit messages. And you can have also a release node generator that try to auto-produce a changelog based on your semantic commits, the history of your semantic commits, and a GitHub plugin, for example, even if we are in a platform agnostic solution, we assume that, of course, your open source code will be at least on GitHub. And the plugin of GitHub will auto-publish for you the release page. For example, it will link to the tag that Semantic generated and put it on your code base on Git. Let me now share with you a few definitions that will help us to understand an example of workflow I will present in the last couple of slides. All of you know what is a protected branch. Is a branch that is a long-lived branch that you can create at repo startup, but of course if you have an ongoing project, you can create whenever you need. The most important thing is you will not delete this branch, and this branch will receive a merge from eventually from a feature of a fixed branch where you are developing a new feature on a fix. And when you merge onto a protected branch, you will trigger a special kind of release. We will see in a few minutes. We call pre-beta, main, of course, as protected branches. we call a pre-release branch a particular branch that for Semantic will produce a pre-release version. And a release branch is a branch that produces a release version. In particular, a pre-release for us is a kind of release that is for internal use only. You are developing in your team, you want to test. As a matter of fact, you see that the version number, in this case, will be stay fixed during the iteration you do on your branch. And you see that a label, a suffix, will be incremented. So you can start with version 1.02 beta.1, then you iterate again, you got a beta.2, and then a beta.3, and so on. Because version 1.0.2 is a version you will be released to the wider public when it reaches a good stability. Okay? A release is a pre-release that becomes a release, a release that you will distribute to a wider public when you are ready to give to your customers, for example. And finally, there's the concept of a channel that is just a label of a distribution channel. You do not have exactly a channel on PyAPI, but the concept is widespread on other package registry like NPM, for example, or even on Maven. You have special tags that enable you to get the latest stable or beta version, for example. And you can configure Semantic to publish on this, eventually on this channel. Okay, and now we are almost at the end of my part. In this slide, we will see a particular way of managing your repository. You maybe know that there are a lot of flows. You maybe have heard the Git flow, the GitHub flow, or the GitLab flow. I strongly suggest you that to see the recipes that are on the Semantic Release website. There are just a couple of them. We will use for demo reasons the pre-release receipt. In this example, you will see how developers act with your repository when Semantic is installed. So you are a developer, of course, and you want to develop a new feature. And you start a new feature so that needs to be tested, of course. You started making a branch, a feature branch at step 1 from the protected branches pre-beta. You start from version 1.0.11 beta 6. You create your feature branch, your pull request. You remove the draft flag after a few iterations. Now you are waiting for your code review. And at step 2, the code review is okay. So someone tells you that it looks good to him. And on step 2, he will decide that it's time to merge your feature branch on pre-beta, generating a new version that is 1.0.11 beta 7. Please have a look at the fact that we have a new meaning. Merging on pre-beta for us means also that you can trigger a deploy on an environment, for example, the development environment. Then, again, you are done, but your release manager, looking at the calendar, see that the release date has been reached. So he decides that it's time to publish a new stable release. He will open a pull request to merge pre-beta on main, and this will trigger a new release to a production environment with a new tag that is 1.0.11, because the pre-release version is now a release version at step 4. Okay, that's all for me. And just we have a look because we need at least one slide with an example of code. This is an example of the descriptor of Semantic Release in YAML format. On the blue lines are just plugin configuration that you can add to Semantic to have a more more behavior added, and the green line are configuration to see semantic acting on branches that are defined as pre-release branch, for example, the pre-beta, or the main branch with the relative channels. And we have also a possible maintenance branch. This is the other strategy you can find on the Semantic Release site for organizing and managing your repository. Okay.
Okay. Okay. Now we are in the. Oh, aspetta. Okay. Now we are in the part we call it tool. In this part, we will show you how the technology behind our solution. And in this slide, we will show you the approach we have used to make this choice. First key point, we want to build a vendor agnostic solution. So we select all the open source projects that best fit our needs, the ones with the large community and the most active ones. Then we want to build a cloud native solution, specifically a Kubernetes native solution, because it's our target environment. Is the most commonly used in microservices architecture. And finally, we use a combination of two best practices, DevOps and GitOps, for design our solution. We'll see it later. Now we show you the technology stack behind our solution. The main core of our versioning system is Semantic Release, that the one that make the new version. In the left part, there is the continuous integration part with GitHub as the choice for the GitHub repo. But any other solution will work fine. Then there is Tekton, an implementation for our CI pipelines. And in the right, after Semantic, there is the continuous deployment part with ArgoCD, a GitOps tool that do the deploy to the final destination. In this case, we choose GKE, but any other distribution will work fine, naturally. In the bottom, there is the life cycle of our software. The code starts by pushing in the GitHub. Then Tekton runs the pipeline locally, build the code, the test, the unit test, create the Docker image of our software. Then Semantic Release, read all the commit message from GitHub and find the new version of our software, for example v100, then use this tag to push the image Docker the Docker image to the Docker Hub, in this case. If our software is a library, for example, use the same version to push to the package manager, for example PyPy. And then we use this information, the new version of our application, to update the EAC repo, the repo dedicated to the deployment descriptor of our application. So ArgoCD, the GitOps tool, use this information, okay, about the new version to update the version, the application version in the JKE. In this case, using Helm chart. And finally, we have the pod of our application running in the correct version in the final environment. Now we are talking about Tekton. What is Tekton? Tekton is an open source CI implementation natively in Kubernetes that use a group of building blocks called tasks that implement all the steps of the pipeline, and you can find this task in a large catalog, in a community-driven catalog. You can also use this repo to put your code. We are here to see how it works. Now there is an example of pipeline. We are in Kubernetes. Every task in this pipeline is a pod running in Kubernetes, have access to a config map where you put your configuration, and you can store the state in PVC. Now we are talking about Tekton. The deployment part is a GitOps, okay, GitOps tool. Here we have how it works. The developer push the code in the GitHub repo. Argo fill this update and synchronize the Kubernetes with the version we put in this repo dedicated to the deployment part. There is also a notification engine that can use it to notify the new version of application in this in a notification channel like Slack, for example. Now there is an example of a configuration. Okay, there's a kind of application where you can put all the configuration of the notification of our application, the destination, where to deploy our application, the source, the EAC repo, and then a sync policy. And now we have the overall solution here in the slide of our solution. In the left, we have the CI part, and in the right, the deployment part. The flow starts with the developer that push the code in point 1 to the code repo. Tekton fill the notify about this update and run the pipeline. You have the tasks, for example, the clone the repo, then the build, and then there is a semantic task that define the new version of application by reading the commit message, and use this tag to tag the code, push the image to the image repo, and eventually publish in PyPy, the same version. Then there is an update task that uses this version to update the EAC repo, okay, with the same version. Then ArgoCD discover that there is a new version of our application and deploy to the, for example, dev namespace. And finally, there is the notification about this new application in the Slack channel. Now we cannot do.
I think that we can end here and leaving a few space to your question, because we have a couple of videos that you will find on our repository, and feel free to ask for a version. We have no time to show this couple of videos. They are CI execution. You can, of course.
Again, we have a couple of questions, Slido.
Thank you. Thanks.
And I think if we have some time after the questions, you can still show one of the videos maybe. Let's just see how much time there is. But there's plenty of questions in Slido. Keep them coming. Let me just accept a few first. So the first one is, how can you assure that multiple features do not interfere with each other or with the repository management flow, since all the feature branches are merged in the pre-branch?
Sorry.
Okay. So basically, How can you assure that multiple features do not interfere with each other, like with the repository management, if you have multiple feature branches and they're all being merged into the pre-branch?
Okay, this is about the repository management. If you see that you can mix both strategy, the pre-release strategy and the release management, strategy, we have not shown in this talk, of course, but you can, with these two kind of strategy on your repository, you can both have multiple development or multiple version. For example, you can have support to an actual released version that could be 1.2.1, and you have to do fix or new features, while you are developing a future beta version that could be a breaking change at 2.0.0. And you will iterate a lot on the beta version while you are supporting the already released version. Take care of the fact that this question is just on the management of the Git repository. So if you tag each version, you are able to deploy to code without having interferences on released version and pre-release version. I can, of course, we do an example later if you want.
Sure. So another popular question is why or how do you force people to actually follow the semantic commit standard? Is there any enforcement in there?
That's a really good question. Otherwise, of course, if you do not have semantic commits, this is absolutely useful-less. But there are a few tools, for example, that can help the developer. There's one tool I saw in the command line. It's called committed. It should be written in again in JavaScript, but you can install on your CLI. And committed will help you with a few questions each time you want to make a new commit. Okay. There are solutions that can do practically the same thing using just committed, but committed is not born to be put inside the CI workflow. That's why we suggest you to use a tool like committed that guide the developer to redact a commit message without knowing or remembering the format of a semantic commit message. But just used for this kind of operation. Otherwise, you should think that developers should learn, and you have to, of course, dig with this thing. But it's a small one. I think that each one of you write a commit message. It's just, I think it could be easy. We got several teams a job that they're using semantic commits.
Yeah, it might take some time to get adjusted, right? We all know how we are as developers if we have a used routine. But there's several questions on the choice of Tekton. I'm just going to try to summarize them. It's mostly about why you chose to use Tekton instead of GitHub Actions or maybe Jenkins for your tools.
Because we want to be independent, okay, to the vendor of the solution. So we chose a solution that works directly in Kubernetes without any other needs.
Yeah. And maybe back to the commits. Are there any rules about how to semantically write commit bodies in semantic conventional commits? So apart from the commit message, how do you write the body? No,
the body is absolutely free. You can write whatever you want. The first line should be in 80 chars, not more. But in the body you can write lines, and I strongly suggest you to write a few lines, because the body will end in our solution inside a changelog markdown file that is pushed on the root of your repository. Each time you will trigger a release, a new changelog will be auto-added with your commit message and what you've written inside the body. So it's quite useful to write the body if you want. Otherwise, just skip and leave it blank. But it's up to you.
Another question is, what if there are multiple feature branches before merging the beta branch into the main branch? How do you handle that?
Okay, this is again about the repository management, but I have to make you an example that is a little big, but I remember that on the semantic site, in the documentation, there are 2 pages dedicated to 2 different recipes for repository management. So you can mix both the pre-release version that I presented here and the release receipt to achieve a scenario where you can have multiple versions developed by developers, and you can, of course, scale the solution to develop and deploy on different versions on different environments, and also, if you want, on environments of different customers. Okay, this is require a bigger step. It could be not so easy because you have to elaborate the CI and the Tekton part a bit more. But at least you will have a complete example on the repository, so you can have all the stack up and running. But I'm open to discuss this with each one of you after the...
Yeah. Unfortunately, we don't have time for any more questions. Thanks for all the questions. Again, thanks to Simone and Luigi.